Okay, finally we have projectile motion. This is sort of the ideal motion for, say, a baseball or anything that's been thrown up in the air, but not directly up in the air. So anything that you throw should have sort of a parabolic shape. So when an object is accelerated only by gravity, then it moves in a parabola. And there are two important things about that. One, has uniform motion, no acceleration in the x direction, and it has uniformly accelerated motion in the y direction. Okay, so that means that the x direction is proportional to time, and so your y-t graph ends up being your xy graph, right? So I mean, it's perfectly useful sort of thing. So the technique is the same, right? We want to break this up into two equations. So for uniform motion, x of t was x0 plus vxt. We may as well make that a vx0. Vx is not changing. So we're okay with that. And for the y direction, we had vy of t is vy0, or I guess it's minus g of t. Whoops. All right, so that's perfectly fine, but we'd rather have the trajectory in the xy plane. So we need an equation for that, and that is very similar. You can use these equations plus that average velocity equation if you'd like, the uniformly accelerated motion condition. That and you can use that to actually find that y0 is equal to y naught plus v naught y times t minus 1/2 gt squared. So that's why it's a parabola, because this is squared here. That means it's a parabola. Okay, so that's what we have. There should be a minus sign. So again, we have to start with our initial position, which is x0, y0, which is something like that. So that's r0, and this is y0, and this is x0. And then we have a trajectory, which is a parabola, something like that. Our initial speed is sort of parallel tangent to this parabola, so it's going this way. That's our initial speed, v0. Okay, so that's more or less what's going to happen is we have this path for like the baseball. This is where you first saw the baseball. Possibly y0 is around 3.5 feet. That would probably be, where it was hit. v0 would then be its speed after it was hit. And now we have a path for the ball using these two equations. If we find some other point on the path, that's our r of t. And this could be any point on the path. Just you have to choose one to draw it. And then our velocity is at some funny angle here. So you'll notice this is not 0. This is a velocity at the time t. You'll notice that these arrows for the velocity are changing. We know that because this is changing. Actually, the x components should be the same, and the y component for the velocity is changing. That means there's no zero velocity at this point, right at the apex. It's still moving horizontally. It has that Vx there, and that same Vx the entire way through. So that's basically how a ball flies through an air. through the air. And, so yeah, that's projectile motion. I'll give you some problems and move on to some circular motion next. All right, bye now.